Hello everyone, this is MJS Pawan. In this video, we will discuss about the inhomogeneous and non-homogeneous linear equation. In the previous video, we have learnt about the homogeneous linear differential equation of up to third order linear differential equation. Also, we have discussed some of the special cases when the roots are same and when roots are different and writing the general solution of the differential equation. If you haven't subscribed to my channel, please do subscribe to my channel. Now let's begin. In homogeneous or non-homogeneous linear equation, what happens if there is a term with none of the dependent variable, that is loosely a term on the right hand side? We have seen here like the function of this form, but in the homogeneous case, what you have here, this term is 0. In the non-homogeneous case, there is some dependent sum of the variable is present here on the RH side. This is the non-homogeneous differential equation. In the most general cases, we don't do anything, but in one or two special cases, we can. If you already know the general solution of homogeneous equation, like f2 of x is equal to d square by dx square plus f1 of x into dy by dx plus f0 of x is equal to y. So we are in the previous video, we have solved that when the RHS side was 0, that was in homogeneous, we got the general solution of the form of y is equal to c1 y1 of x and y2 of x. So these are the root what we have find out in the previous class. So I'm just continuing with this. Next, then we all we know to find here is the particular solution, because here there is an g of x is present on the other side, so it is, since it is a non-homogeneous differential equation, so we need to find the particular solution for this differential equation. The general solution of the whole equation is of the form will be y is equal to cy1 plus c2. Like, this is called as complementary solution and this is called as pf solution. The solution of homogeneous, what I told, this is the CF part, and the particular of u of x is called as particular integral, what you usually call. For finding the particular integrals, there will be a lot of trial and error methods involved in it. So before going to that, let's consider some special cases when coefficient is x power r. This is x power r. Okay, of the form x power r. In the previous video also I have discussed when the case is x power r. Similarly, in the case of non-homogeneous differential equation, how does this work? Let's see. In this case, we can only cope up with some specific kind of RHS, a polynomial. We'll see an example like x square d square y by dx square minus 6x dy by dx plus 10y is equal to 6x cube. The homogeneous equation of, in this case, one we have seen before, is how we can write x square d square y by dx square minus 6x dy by dx plus 10y is equal to 0. This of the form. So what we are going to do is take the form y is equal to x power m and find out this value. Like, you will be getting m into m minus 1 minus 6x 6 into plus 10. So this will be m square minus m minus 6m plus 10. So m square minus 7m plus 10. 5 2s are 10. So m square minus 5m minus 2m plus 10. So when you solve this, you will be getting the roots as m1, that will be equal to 5, and m2, which will be equal to 2. So we know that we have to substitute in the complete solution, that is CF. So the homogeneous part of the general solution will be is the form of this when we take x power m. So next, now as long as the power on the right hand is not a part of CF, we can find the particular integral by trying a multiple of right hand side. Like how we can do the multiply? Like y is equal to a into x cube. Like here in the equation we have 6 into x cube. So here we are considering this as a some constant and x cube as same as this. And what we are going to do is here just equate the ls side is equal to RHS side. So solve y is equal to ax cube. Differentiate with respect to x, 3ax square. Again differentiation, 6ax. So substitute this of the same equation, keeping the 6 as constants. So then x square ax minus 6x minus 6x, here is minus 6x, 3 into ax square, here there is a plus term, so there is a 3 into ax square plus 10x, 10 into y is ax cube. Similarly, take x cube common out here, here there is a x cube, here there is x cube, then you are end up with 6a minus 18a plus 10a. So solving this, 6 plus 16 minus 8, 16 minus 18 gives you minus 2, because here there is a minus, 18 is greater than 16. So for this two-way solution we need minus 2a is equal to 6. Like how it is written is like we have taken consider the RHS part, 6x cube is equal to minus 2x cube. So here x cube get cancelled. So what is the value comes is minus 2 ones are 2 threes are. So here minus 3, a is equal to 3. The general solution of this full equation is like y is equal to c1 x square x power 5 plus c2 x square minus 3 x cube, because here consider the x cube. Some of the care should be taken while solving this kind of differential equation. If the polynomial of for a power m has the repeated roots, then we cannot use this method. If the polynomial of the power m has the complex root, then also we cannot use this one. If the power of the RHS matches a power of CF, then we fail. Means what the CF we got, suppose this has a power of x square. If the PI also has the same power of x square, then we cannot use this method. Similarly, if the term contains some of the complex root e power x or some e power I theta form, then we cannot use this method. Also, I repeated repeated roots. In the previous video I have discussed about the repeated roots. So suppose like m1 is equal to 2 and also m2 is equal to 2, we can't use this method. So this method get failed. For doing such kind of containing e power ix and repeated units, there are some other cases which will be going to discuss in the upcoming videos. Let's go for an example. D square y by dx square minus 3 dx by dy by dx plus 2y is equal to e power x. First we need the CF. Like here we have to take y is equal to lambda x, because here the constant coefficient present. So we have to take the e power lambda x. Now same thing as done in the previous video, like do the first derivative, lambda into e power lambda x, lambda double dot is equal to lambda square e power lambda x. So after substituting into this equation, you will be getting this solution, this equation. And what is the roots of this equation? Is lambda is equal to 1 and lambda is equal to 2. The CF is then comes to be y is equal to c1 e power x plus x2 this c2 into e power 2x. Then y is equal to a e power minus x. Like I told, you have to consider the right hand side. Here there is a term 1, so you have to consider a e power minus x. A we have taken because here some constant 1 is present, minus a, that is a e power minus x, because e power minus x term is present here. Dy by dx, differentiate, you will be getting minus a e power minus x, d square y by dx, then you will be getting minus of minus plus, it will become a into e power minus x. Next we need to find the pi, since e power x is present on the RH side. So just put the equal the LHS is equal to RHS, like d square y by dx is equal to a into e power x plus how plus become minus 3 is there, 3 times minus 3 times minus a into e power x, that become plus 3a e power minus x. Then 2y, y is a into e power x. Next take the e power x common, no common, just add this all the term, you will be getting 6a e power x. Now equate this term with e power minus x, so you will be getting a is equal to 1 by 6. So then our particular integral will be 1 by 6 e power minus x. So then the general solution will be for the differential equation is this expression, which is a combination of complementary and particular integral. Thank you for watching. If you like this video, please like it and share with your friends. Don't forget to subscribe to my channel. Thank you.